Imagine the sky above you, silent, dark, scattered with points of light. Each point is not just a star, but part of a vast city of stars, a galaxy. Our own Milky Way is just one among countless billions, drifting in the quiet sea of the universe. And though it feels eternal, nothing in the cosmos ever truly stands still. Every galaxy is moving, pulled and pushed by the invisible thread of gravity. Now picture two galaxies, enormous, delicate spirals, slowly drawing closer across millions of years. They look calm, almost frozen, but the truth is far from it. This is not destruction, but a dance. Stars are stretched, dust is stirred, black holes awaken, and new suns are born. It's not chaos, but a story, written in light and time, unfolding in ways we can barely imagine. Tonight, we will follow this journey step by step, moment by moment, from the first subtle whispers of attraction to the final embrace where two galaxies become one. The question is not if galaxies collide, but what happens when they do. So close your eyes, relax, and let's drift into the grandest story the universe tells. A universe always in motion. Everywhere you look in the universe, movement is constant. Galaxies rotate like giant pinwheels, their stars swirling around invisible centers. Clusters of galaxies drift together in filaments, bound by gravity's patient pull. Even the space between them is not truly empty. It expands, stretches, and carries them further apart, even as some are drawn toward each other. Imagine a calm pond where ripples cross endlessly. Galaxies are those ripples, gliding but never still. And yet, from our human eyes, the stars above look frozen. The constellations remain unchanged for lifetimes, tricking us into believing the universe is static. But on deeper scales of time, nothing is unmoving. Our Milky Way is racing through space at hundreds of kilometers every second, and so is Andromeda, our great neighboring galaxy. They are destined for a meeting, though to us it seems impossibly far away. Still, the motion is already underway. It's a strange truth. What looks permanent is actually in flux. Even mountains on Earth rise and crumble, though we can't see it in a single lifetime. Galaxies follow this same hidden rhythm. They twist, drift, collide, merge. Stillness is an illusion, and movement is the real law of the universe. This endless motion is not wild chaos, but a kind of quiet choreography. Each galaxy carries billions of stars, planets, and nebulae, and all of them together obey the invisible hand of gravity. Like dancers who never stop moving, galaxies are guided by steps too slow for us to notice, but too grand to ever stop. Some drift apart forever, while others move closer, locked in a path toward eventual meeting. And when two do meet, the universe writes one of its most dramatic chapters. So when we speak of galaxies colliding, we're not talking about sudden crashes or explosive violence. We're speaking about an ancient, inevitable rhythm, the way everything moves toward transformation. That's why understanding galactic motion is like listening to a secret pulse of the universe. It reveals that change is not an exception. It's the only constant that exists. Galaxies as drifting islands of stars. A galaxy is like an island in the endless sea of space. Each one contains billions, sometimes trillions, of stars woven together by gravity. Imagine standing on a shore watching faint lights on distant islands drift slowly across the horizon. That's how galaxies exist, each carrying their own storms, their own histories, their own quiet beauty. From far away they look serene, but up close they are alive with energy. Inside these islands, stars orbit around central masses, gas clouds collapse into new suns, and black holes silently anchor the core. Each galaxy is its own city of light, but unlike cities on Earth, they drift for eons, rarely meeting. Still, gravity links them all, like invisible bridges spanning the cosmic ocean. No galaxy is ever truly alone. We sometimes think of galaxies as solid objects, but they are not. They are mostly empty space with stars so far apart that if you shrank the sun to the size of a grain of sand, the nearest star would still be kilometers away. This emptiness is what makes galactic encounters so strange. They are collisions without crashes, dances without direct strikes. And yet even in that emptiness, galaxies feel each other's presence. Their invisible halos of dark matter extend far beyond their stars, brushing and tugging long before the galaxies themselves appear to touch. Like two ships in a fog, sensing each other by ripples on the water, galaxies sense one another by the distortions in gravity. This is the beginning of a meeting that will reshape both forever. So when we say galaxies drift, it's not passive wandering. They are pulled, redirected, sometimes captured, sometimes set free. And when two paths converge, those drifting islands stop being separate. They become one larger island, more luminous, more massive, carrying new stories written across the stars. And in that transformation, the universe shows us its deepest secret. Even destruction is a kind of creation, the invisible pull of gravity between them. Gravity has no edges, no walls, no borders. It stretches infinitely, tugging on everything, no matter how faint. Between galaxies, it acts like a thread drawn tight across unimaginable distances. Even when galaxies seem impossibly far apart, their halos of dark matter and stars already feel that pull. It begins softly, almost unnoticed, like the first note of a long song. At first, the tug is so subtle it's invisible to our eyes. But over millions of years, that tug reshapes the galaxy's paths. They begin to curve toward each other, like two dancers slowly drifting closer in a crowded hall. What feels inevitable is not forced. It's guided by the natural law of attraction, the one rule the universe always obeys. We often imagine collisions as sudden, violent moments, but the pull of galaxies is more like a tide rising quietly. They sense each other across millions of light years, moving gradually into a shared destiny. The closer they draw, the stronger the pull becomes. It is a slow spiral inward, written not in seconds, but in hundreds of millions of years. And it is not only the galaxies that move, their stars, their planets, their black holes. Everything inside them begins to feel this gravitational song. Stars on the outskirts are tugged first, like threads on the edge of a fabric being pulled. Then the whole structure begins to lean, twist, and stretch. The invisible force becomes visible in the bending of light and shape. This is why gravity is not just a force, it is the weaver of stories. It doesn't crash galaxies together suddenly, it draws them into a dance, shaping every star and every orbit. And when the moment of closeness comes, we can finally see what that invisible pull has been preparing all along. Why galaxies are destined to meet. It might seem like galaxies have infinite room to float, never crossing paths. But the truth is different. Gravity doesn't let them wander aimlessly forever. Groups of galaxies, called clusters, are bound together in larger webs, and inside those webs, galaxies are constantly nudging, circling, and sometimes colliding. Think of leaves in a pond. They may drift apart, but currents always find ways to bring them near. Our Milky Way, for example, lives inside the local group, alongside Andromeda and dozens of smaller galaxies. Though the universe itself is expanding, on smaller scales, gravity wins. Expansion pushes galaxies apart across billions of light years, but nearby, galaxies can still fall toward each other. That's why Andromeda and the Milky Way are already locked on course, like two great ships sailing toward the same harbor. It's not chance, but inevitability. Over long enough timescales, galaxies in the same region almost always interact. The more massive they are, the stronger their pull. Once their dark matter halos overlap, escape is nearly impossible. They are destined to spiral inward until they merge. The only question is how many passes they will make before that final union. And destiny here doesn't mean destruction. It means transformation. Galaxies are not destroyed when they collide. They are reborn into larger, more luminous structures. Some lose their graceful spirals and become smooth ellipticals. Others ignite waves of star formation. The outcome depends on their masses, their speeds, their angles, but the meeting itself is always written in their paths. So when we look at our own Milky Way, we are not looking at something eternal. We are looking at a chapter in a story still being written. Ahead of us lies a collision that will reshape everything we know, not in our lifetime, but written into the destiny of the stars. The first whispers of approach, the first sign of galaxies approaching is not dramatic. It begins at the edges where invisible halos brush. Streams of gas stretch out like fingers. Faint arcs of stars bend slightly as though leaning toward a distant call. These are the whispers, signals that two galaxies have noticed each other. For millions of years they circle closer, and those whispers grow louder. If you could watch it sped up, you'd see galaxies begin to distort. Spirals bend, arms stretch, and faint bridges of stars form between them. These structures are delicate, almost ghost-like, but they reveal what gravity is already doing beneath the surface. It is guiding billions of stars into new paths long before the cores ever meet. To the inhabitants of planets deep inside these galaxies, the approach would be invisible at first. Night skies would look unchanged for ages. Only slowly would constellations shift and faint smudges of light appear where once was empty space. Imagine looking up and seeing an unfamiliar glow rising beside the Milky Way, a slow phantom taking shape in the dark. And with those whispers come changes inside. Gas clouds are stirred, star formation is triggered, black holes begin to feel the inflow of matter. The galaxies are still separate, but already they are influencing each other's heartbeat. What begins as a quiet approach becomes the first step toward transformation. Because the truth is, the story of a galactic collision doesn't start when they finally touch. It starts much earlier, in the faint whispers, in the first invisible threads of gravity that remind us, even across light years, nothing in this universe is ever truly separate. Dark matter's hidden role in guiding paths. Though galaxies look like graceful spirals of stars, they are mostly held together by something we cannot see, dark matter. This mysterious substance makes up most of the mass in galaxies, wrapping them in halos that stretch far beyond the visible light. When two galaxies begin to sense each other, it is these halos that touch first. It is almost like two invisible giants shaking hands long before their cities of stars come close. Dark matter doesn't glow, doesn't reflect, doesn't announce itself. Yet it is the architect of galactic motion. It provides the gravity that keeps stars from flying apart and determines how galaxies travel through the cosmic web. Without it, spirals would unravel, and collisions would look entirely different. The unseen shapes the scene, just as the roots of a tree shape the canopy above. When galaxies drift closer, it is their dark matter halos that merge first, overlapping and creating a shared gravitational stage. The stars and gas inside are just players moving on that stage, responding to forces they cannot see. This is why the dance of galaxies seems so smooth, and the framework guiding it is already in place, invisible but unbreakable. The most astonishing truth is that we still don't know what dark matter is. We only see its fingerprints, the bending of light, the speed of rotation, the way galaxies collide and hold shape. and yet even in mystery it governs their destiny. Collisions are written not just by stars we see, but by the matter we cannot ever touch. So as galaxies approach, it is dark matter that whispers the steps of the dance. It is the hidden conductor, ensuring that the two giants will not simply pass each other by, but spiral inward, entwining until their fates are joined. The stage is already set even before the first stars feel the pull. When halos of gas touch before the stars do, long before stars collide, which they rarely ever do, clouds of gas within galaxies begin to stir. These halos of gas stretch much farther than the luminous spirals we see in telescopes. When galaxies approach, these diffuse clouds overlap first, colliding gently and compressing under pressure. It's the earliest sign of interaction, invisible from afar but critical in shaping what follows. The collision of gas clouds is not quiet. When they meet, shock waves ripple through them, heating the gas to millions of degrees. This hot plasma radiates in X-rays, glowing faintly to astronomers who can see beyond visible light. It is the universe's subtle alarm bell announcing that galaxies are no longer alone. They have begun to influence each other deeply. Inside these gas clouds, star formation is triggered. Pressure builds, collapsing regions into bright newborn suns. Entire clusters light up, scattered like sparks between the galaxies. It is almost paradoxical. From the collision of cold clouds comes the birth of warmth and light. In cosmic terms, destruction is inseparable from creation. Meanwhile, some of this gas is stripped away entirely, flung into long tails trailing behind the galaxies. It may drift for millions of years, eventually cooling and forming stars in isolated pockets far from any core. These wandering stars are like exiles, proof of a meeting that stretched galaxies into strange new forms. So even before the great spiral arms truly intertwine, the halos of gas have already begun the story. They are the first to touch, the first to spark change, the first to reveal that a new chapter is opening between two drifting giants of light, ripples spreading through intergalactic space. The universe may seem empty, but when galaxies draw near, even the surrounding space begins to ripple. These ripples are not water waves, but gravitational waves, shock fronts of heated gas, and subtle distortions in the cosmic background light. Like dropping two stones into a pond, their overlapping influence creates patterns that spread outward into the dark. Sometimes these ripples are visible as arcs of faint stars, stretched thin like threads across the void. Other times they appear as great streams of gas, bending into bridges that connect the galaxies. To astronomers, these faint traces are the first, undeniable signs of collision, the fingerprints of galaxies beginning their embrace. The ripples can also disturb smaller galaxies nearby. Dwarfs orbiting around the larger ones may be tugged off course, captured, or even shredded by tidal forces. It is as though the entire neighborhood feels the tension, not just the two giants at the center. One meeting between galaxies can reshape an entire region of the universe. Even light itself feels the ripple. As gravity bends space, background galaxies far behind the collision can appear stretched, warped, or magnified, a cosmic lens created by mass in motion. This effect tells us not just that galaxies are colliding, but how much invisible matter surrounds them. So when galaxies drift close, the ripples are not contained. They echo across space, carrying the story outward. Even the silence of the cosmos is disturbed, and those disturbances become the signals we use to understand what is happening in the grandest of dances. The first stars to feel the tug. In every galaxy, stars orbit in delicate balance, held by gravity's invisible grip. But when another galaxy drifts near, some stars begin to feel a second pull, one that disturbs their steady paths. The stars on the outer edges, farthest from their core, are the first to notice. They are tugged slightly off track, leaning toward the oncoming neighbor. Over time, these stars stretch into long arcs called tidal tails. To the human eye, they look like ghostly bridges of light reaching across the void. These tails can extend for hundreds of thousands of light years, like luminous scars marking the interaction. The stars themselves don't collide, but their orbits are rewritten. Some stars may even be stolen. Captured by the gravity of the intruding galaxy, they switch allegiance, becoming part of a new family of light. To those who might watch from a planet, the night sky would slowly change, constellations melting away as their suns are drawn into foreign orbits. The tug is not violent but patient. Stars drift gradually, carried by forces they cannot resist. Some are flung outward into the intergalactic void, destined to wander alone, untethered to any galaxy. These rogue stars are silent witnesses to the collision, carrying its memory into the darkness. Thus, even before the cores come close, the outskirts of galaxies already tell the story. The first stars to feel the tug become the messengers, tracing elegant tails and streams across space, showing us that the embrace has already begun. Galaxies begin to stretch and twist. As the pull grows stronger, entire galaxies start to deform. Spirals no longer remain neat. Their arms stretch, twist, and bend into new shapes. The once graceful disks warp, curling into strange arcs as though the galaxies themselves are being sculpted by invisible hands. It is a reminder that galaxies are not rigid, but fluid, able to stretch like fabric when tugged. This twisting creates astonishing structures. Some galaxies form long bridges of stars, linking them directly to their partner. Others develop rings or shells, patterns that would never exist without the pull of another galaxy. Each collision writes a unique signature, like fingerprints in the sky, telling of a one-time encounter, never to be repeated. From far away, these twisted forms look almost like artworks. Giant cosmic brushstrokes across the black canvas of space. The beauty is deceptive because it emerges from enormous gravitational stress. But in that stress lies transformation. The old shapes are sacrificed to create new patterns, new balances, new galaxies entirely. Astronomers who study these warped shapes can even reconstruct the story backward. By tracing the twists and tails, they can see how galaxies approached, how close they came, how fast they were moving. The deformations are like frozen echoes, preserving the history of a dance billions of years old. So when galaxies begin to stretch and twist, we are not just witnessing chaos, we are watching the universe in the act of creation, reshaping what exists into something grander. Each twist is a step in the choreography, each stretch a line in the unfolding poem of the stars. Tidal forces sculpting long, cosmic tails. When galaxies draw close, gravity does something remarkable. It stretches them like taffy. These stretches create tidal forces, the same kind that the moon uses to pull Earth's oceans, but on a scale almost beyond comprehension. Instead of water, it is entire rivers of stars being tugged away, forming luminous trails that extend hundreds of thousands of light years. These tails are the signature of a cosmic embrace, carved into the sky like brushstrokes across black velvet. The beauty of these tidal tails lies in their fragility. They look faint, ghost-like, barely clinging to the galaxies that birthed them. And yet they are vast, containing billions of stars and uncountable amounts of gas and dust. These streams arc gracefully, some curving back toward their parent galaxies, others stretching into the emptiness, carrying light into regions where there was none before. For astronomers, tidal tails are living records of collisions. By studying their shapes, their twists, and their direction, scientists can replay the entire dance, tracing the steps galaxies took across millions of years. Like footprints in sand, these tails are temporary, destined to fade, But while they last, they speak volumes about the forces at play. Some tales even give birth to new galaxies. Gas within them can collapse under its own gravity, sparking star formation that grows into small satellite galaxies, born not in isolation, but from the drama of collision. The act of stretching does not just scatter, it also seeds creation in the void. So when we see long tails trailing behind colliding galaxies, we are looking at more than scars. We are witnessing creation and destruction braided together, the elegance of cosmic tides, sculpting new shapes from ancient spirals. Dust and gas clouds stirred awake. While stars shine brightly, the true engines of transformation during collisions are the clouds of gas and dust hidden within galaxies. These clouds are often quiet, drifting in balance, till the gravitational pull of a passing galaxy shakes them awake. Suddenly pressure builds, turbulence rises, and these once still regions collapse into storms of creation. Like a spark in dry wood, collisions ignite the hidden fuel of galaxies. When gas clouds collide, shock waves ripple through them, compressing the material into denser regions. In those regions, gravity takes over, pulling matter together until nuclear fusion begins, and new stars are born. It is almost as though the galaxies themselves inhale deeply, then exhale in bursts of new light. Entire clusters of young stars ignite at once, filling regions with brilliant blue light. But this awakening is not always calm. Gas heated by shock waves can also be driven out of galaxies entirely, expelled into space where it may never form stars again. In this way, collisions both create and destroy. They feed star birth in some regions while starving it in others. The balance is delicate, and the outcome depends on how the galaxies meet. Dust, too, plays its role. These tiny grains, no larger than smoke particles, are stirred and illuminated by newborn stars. They scatter light, painting galaxies in glowing shades of red, gold, and blue. To telescopes sensitive to infrared light, colliding galaxies blaze like bonfires hidden behind veils of dust, showing us the intensity of their awakening. So when galaxies stir their clouds awake, they create a paradox: chaos and beauty, destruction and renewal, all happening at once. It is in these dusty nurseries that the universe writes its most poetic lines, reminding us that out of disturbance comes life. Old stars thrown into strange orbits. Not all stars are born anew in collisions. Many are old, long settled into orbits that felt permanent, until another galaxy arrives. Suddenly the balance breaks. These ancient stars are hurled into strange paths, some slingshot outward, others captured into elongated loops. To the stars themselves, nothing changes. They burn as they always have. But their journey across the galaxy is forever rewritten. Some are pulled into vast tidal streams, circling far beyond their original home. Others are trapped in the gravitational tug-of-war between the two merging galaxies, looping back and forth like pendulums in a cosmic clock. These distorted orbits give galaxies their twisted shapes during collision, bending spirals into arcs and shells that shimmer faintly in the dark. To anyone living on a planet orbiting one of these wandering stars, the change would be subtle but profound. The night sky would shift slowly, constellations dissolving over millennia as the star drifts into new neighborhoods. Galaxies do not collide violently for the stars inside. They simply rearrange the stage, moving actors into new roles in a drama billions of years long. Sometimes these old stars are flung into intergalactic space, becoming rogue wanderers without a galaxy to call home. Though alone, they still shine, carrying the memory of the collision in their lonely journey. The universe holds countless such exiles, unseen yet ever present in the silence between galaxies. Thus, collisions remind us that even the most ancient and stable things are never truly fixed. Orbits can be rewritten, paths can be redirected, and even stars that seemed eternal are guided into new stories by the gravity of passing giants. Young stars caught in gravitational tides. If old stars are moved gently, young stars feel the tides more dramatically. These are the hot, brilliant blue stars born in the aftermath of gas clouds colliding. They burn fiercely and live short lives, often only a few million years. And in the gravitational tides of colliding galaxies, their brilliance becomes both a gift and a fleeting memory. Young stars cluster in dense knots, glowing like lanterns strung across tidal tails and bridges. From afar, these star-forming regions look like jewels scattered on strands of silk. They tell us where gas was compressed most tightly, where the tides turned chaos into creation. Each knot is a stellar nursery, blazing with energy. But these tides also make young stars vulnerable. Some clusters are stretched apart, their stars scattered before they have time to bind together. Others are pulled into strange orbits that carry them far from their birthplaces. Unlike old stars, these luminous youngsters are fragile, easily swept along by the tides of collision. Their brilliance, however, makes them the markers of the event. They shine so brightly that telescopes can see them across billions of light years, allowing us to witness collisions from the distant past. In this way, young stars are both victims of tides and storytellers of history. So when galaxies collide, the young stars born within their tides remind us of something deeply human. Beauty can be brightest when it is brief, and stories can echo across unimaginable distances even after the lights themselves have gone out. The slow ballet across millions of years. Perhaps the most humbling part of galactic collisions is their pace. To us, collisions suggest sudden crashes, instant sparks, but in the universe, these meetings are slow ballets stretched across millions, sometimes billions of years. What seems like chaos is actually choreography, unfolding in steps too vast for human senses to follow. The first approach takes hundreds of millions of years as galaxies drift closer. The first pass may take another 100 million, flinging out tails and bridges. Then they may separate slightly, only to be pulled back again for another embrace. This dance can repeat many times before the final merger. Each pass creates new shapes, new bursts of star formation, new twists in their spirals. Like dancers circling, they draw closer with every turn until, at last, their cores meet and their stars settle into a single, shared system. To us it feels unimaginable, yet the universe waits patiently for the dance to finish. If we could speed up time, the dance would be breathtaking, spirals stretching, arms entwining, tails flaring out and fading, until two galaxies blend into one larger form. No sudden crash, but a flowing choreography, as if the universe itself were painting with stars. So galactic collisions are not battles, they are ballets. They are the universe's way of showing us that even the grandest transformations unfold slowly, gracefully, and with a beauty that requires patience to truly see. Star clusters born from cosmic compression. When galaxies collide, gas clouds don't just stir, they collapse into clusters. These clusters are like nurseries where thousands of stars are born together, bound by gravity. Imagine a single spark lighting not one candle, but an entire chandelier at once. That's how galactic collisions create brilliance. Stars igniting in groups so dense they rival the glow of entire spiral arms. These clusters often contain the brightest, hottest stars. They blaze in vivid blues, their light piercing through veils of dust. From far away they appear like knots of brilliance threaded into the tidal tails. For astronomers, these clusters are beacons, showing where the galaxy's pressed gas clouds hardest, like fingerprints of the collision itself. But life inside a cluster is intense. Stars form close together, their gravity tugging constantly on one another. Planetary systems may struggle to survive in such crowded neighborhoods disrupted by passing suns. Still, the cluster itself holds firm, often surviving long after the collision has ended, drifting as a new jewel across the universe. Some clusters may even evolve into globular clusters, dense, spherical collections of stars that orbit galaxies like satellites. In fact, many of the globulars we see today may be remnants of ancient galactic encounters, silent witnesses to collisions billions of years ago. So collisions do not only stretch and twist galaxies, they plant seeds of light that survive for ages. Out of the chaos of compression, order is born, entire families of stars bound together, glowing for billions of years, shockwaves lighting up nebulae. As galaxies interlace, the collisions of gas clouds send shockwaves rippling across nebulae. These waves compress gas, heat it, and make it glow. To our eyes, these regions become radiant, painted in pinks, reds, and blues, the colors of hydrogen, oxygen, and sulfur lit by the newborn stars. It is like watching a fire sweep through a forest, not destroying, but illuminating the hidden beauty inside. These glowing nebulae become some of the brightest features of colliding galaxies. Astronomers call them emission nebulae, giant regions where the energy of hot stars excites atoms, making them shine like cosmic lanterns. In galaxies like the antennae, these nebulae sparkle like jewels scattered through chaos. The shock waves do more than paint the sky. They also sculpt the gas into intricate forms, pillars, arcs, and shells that twist like cosmic sculptures. Within these shapes, new stars continue to form, their light further illuminating the clouds that cradle them. It is a cycle. Shockwaves ignite stars, stars ignite nebulae, nebulae ignite wonder. But the beauty has a lifespan. As young stars grow and explode as supernovae, they scatter the gas, dimming the nebulae. The brilliance we see is fleeting, lasting only a few million years. But in cosmic terms, that is the blink of an eye, a brief chapter in the endless story of galaxies merging. So shockwaves remind us of something deeply human. Even in turbulence, beauty emerges. The glowing nebulae of colliding galaxies are like fleeting songs, dazzling, emotional, and unforgettable before fading quietly back into silence. The rise of brilliant starburst regions. When galaxies meet, star formation doesn't just increase, it explodes. Astronomers call these periods starbursts. In just a few million years, more stars are born than would usually form in hundreds of millions. It is as if the galaxy is suddenly alive with fire, its quiet simmer replaced by a roaring blaze of creation. Starburst regions can outshine entire galaxies. Their light floods across space, carried by hot, massive stars that burn fiercely and die quickly. From Earth, colliding galaxies undergoing starbursts are some of the brightest objects we can see, their intensity unmatched by calmer galaxies drifting alone. The reason is simple. Collisions funnel gas into dense knots where it collapses rapidly. The normal rhythm of starbirth is broken, replaced by a frenzy. In this frenzy, galaxies light up like cities at night seen from orbit. Clusters of brilliance separated by stretches of darkness, each region a new beacon of life. But starbursts cannot last forever. The gas supply eventually runs low, burned out or blown away by powerful stellar winds. When the frenzy ends, galaxies quiet down, star formation slows, and a calmer balance returns. The brilliance is temporary, but the stars it creates endure for billions of years. So, starbursts are like cosmic celebrations, brief but spectacular, full of light and intensity, marking the union of galaxies with fireworks written in stars. New suns igniting by the thousands, Imagine entire neighborhoods of the sky suddenly filling with newborn suns. That is what happens when galaxies collide. Gas clouds, squeezed and shocked, give rise to thousands of new stars at once. Each one is a new sun with the potential to host planets, moons, and even life. Collisions are not the end of galaxies. They are the birth of future worlds. These suns ignite in waves, their light cutting through the darkness. Some form in clusters, tightly packed, blazing brilliantly. Others emerge alone, drifting into stable orbits that will last for billions of years. To watch it sped up would be to see stars flicker into being like candles lit across a vast cathedral. The scale is staggering. In a single starburst triggered by collision, galaxies may form as many stars as our Milky Way creates in billions of years. It is creation, in fast forward, a reminder of how powerful cosmic encounters can be when gravity stirs the hidden reservoirs of gas. But the birth of so many suns also brings death quickly. Massive stars live short, dramatic lives, exploding as supernovae within a few million years. These deaths enrich the galaxies with heavy elements, seeding the material for planets, oceans, and eventually life itself. Collisions are not just about stars, they are about creating the raw ingredients of life across the universe. So every new sun born in a galactic collision carries a promise. A promise that from the meeting of giants, smaller stories, worlds, oceans, perhaps even beings who look at the sky in wonder, may one day unfold. The colors of colliding skies. If we could stand safely inside a galaxy during collision, the sky above us would be unlike anything we know. Instead of quiet constellations, we would see arcs of stars stretching across space, glowing nebulae lighting the heavens and strange shapes filling the night. It would not be destruction, but an overwhelming display of color and form. The theater of galaxies unfolding above. Some skies would glow with brilliant blues from young stars, while others shimmered red from hydrogen clouds. Dust would scatter starlight into golden hues, creating sunsets across the galaxy itself. The heavens would no longer feel static, but alive, changing with each passing millennium. To human eyes, such a sky might feel overwhelming, even surreal. Imagine waking every night to a canvas where new stars appear, old patterns vanish, and vast glowing arcs cross the horizon. It would be like watching the universe paint in real time, each brush stroke lasting generations but never standing still. Astronomers observing from afar already see these colors in colliding galaxies. Telescopes capture them in detail. The antennae, the mice, the whirlpool, each showing us what happens when gravity stirs the palette of the cosmos. These are not exaggerations, they are real visions of what our future sky may one day hold. So the colors of colliding skies remind us of something profound. Beauty is not limited to peace and quiet. Sometimes beauty emerges most vividly from motion, transformation, and change. And in the heavens, that beauty is written across entire galaxies. Central black holes sensing the chaos. Every large galaxy hides a supermassive black hole at its core. These giants sit quietly for most of their existence, feeding only slowly. But when galaxies collide, they are among the first to feel the disturbance. Gas and stars are drawn inward, funneled toward the center by the new gravitational tides. Suddenly, the black hole that once rested in silence is awakened by a feast. It is almost eerie to think of black holes sensing the collision. They do not see or hear, yet the flow of matter shifts around them, like rivers redirecting after an earthquake. Streams of gas spiral down, heating as they fall, glowing fiercely before vanishing into the event horizon. What was once invisible now shines. These awakenings turn black holes into beacons. They emit radiation across the spectrum from X-rays to radio waves as matter compresses and heats. To us, this appears as an active galactic nucleus, a brilliant core outshining the entire galaxy that hosts it. The chaos outside funnels directly into the most silent place of all, turning darkness into light. The feeding can last millions of years, reshaping the galaxy from within. Jets of energy may blast outward, driving gas away and quenching star formation. The black hole does not simply consume, it dictates the destiny of its galaxy, deciding whether stars will keep forming or fade into silence. So, collisions are not just events of stars and dust, they are invitations for sleeping giants to wake. And when black holes awaken, the whole galaxy feels their presence, pulsing with energy that reaches across intergalactic space. Streams of matter funneled inward. One of the most dramatic effects of a galactic collision is the way matter flows inward. Spiral arms are distorted, gas is squeezed, and rivers of material spiral toward the center. To the human imagination, it looks like two oceans colliding and forming whirlpools, pulling everything into deep, unseen currents. This inflow of matter is what awakens the galactic centers. Black holes feed, stars ignite, and new patterns of rotation emerge. The elegant spirals that once defined the galaxies may become twisted, chaotic, as if the galaxies themselves are being reshaped from their hearts outward. The funneling is not a sudden collapse, but a graceful spiral inward. Over millions of years, gas clouds drift closer, tightening their orbits until they finally fall. Stars, less affected by drag, often circle for longer, but even they feel the pull, leaning toward the glowing core like dancers drawn to a stage light. In some cases, these streams form dazzling rings around the center. Gas and stars settle into rotating disks that glow with intense brilliance, shining like cosmic jewels. These rings are temporary, but their beauty is unforgettable, the visible proof of the inward flood. So when galaxies collide, their stories are not only written in the stretching tales, but in the quiet, inward streams. They are the hidden arteries of the cosmic body, carrying matter into the heart where transformations burn brightest. Quasars awakening like cosmic lighthouses. When the inflow of gas into a black hole becomes overwhelming, something extraordinary happens. A quasar is born. Quasars are the brightest beacons in the universe, their light so powerful it can outshine entire galaxies. And many of them are triggered by galactic collisions when streams of matter fall into hungry black holes at incredible rates. Imagine a lighthouse in the dark, but one so brilliant it can be seen across billions of light years. That is what a quasar is. The energy comes not from the black hole itself, but from the swirling disk of matter heated to extreme temperatures as it spirals inward. The collision has unlocked one of the universe's most dramatic displays. For distant astronomers, quasars are like time machines. Their light has traveled across most of cosmic history, telling us about galaxies colliding in the early universe. Some of the first structures we ever saw at great distances were quasars, marking where galaxies were merging, feeding and transforming at the dawn of time. Quasars do more than shine. Their energy blasts gas out of galaxies, shutting down star formation and changing the galaxy's future. They can both give birth to light and silence it, shaping how galaxies grow over billions of years. In that sense, quasars are both creators and destroyers, born from collision yet rewriting what comes next. So when galaxies awaken quasars, the universe itself seems to open its eyes. These lighthouses remind us that in the darkest depths, moments of breathtaking brilliance can emerge, carrying their story across eternity. The merging of black holes on the horizon. As galaxies circle closer, their central black holes also drift toward one another. At first, they orbit at vast distances like predators circling, but over time they spiral inward, pulled together by the loss of energy carried away as gravitational waves. Slowly, inexorably, two invisible giants approach the moment of union. The final merger of black holes is one of the most powerful events in the universe. The energy released in gravitational waves can exceed the combined output of all the stars in the galaxy, but for only a brief instant. It is a pulse of space-time itself, rippling outward faster than light can carry any message. To us, these mergers are invisible to the eye, but not to our instruments. Observatories like LIGO and Virgo have detected the faint whispers of black holes merging, distortions in space-time reaching Earth from billions of light-years away. Each detection is a note in the symphony of the cosmos, telling us where galaxies collided long ago. And yet, the actual black holes do not survive separately. They become one, larger, heavier, more powerful. The galaxy that results carries a single giant at its core, shaping its destiny for aeons to come. The union is permanent, a fusion of darkness into greater silence. So at the heart of collisions lies this final act, black holes merging, silent, unseen, but profound. In their union, galaxies themselves are sealed into new forms, and the universe's deepest mysteries whisper through the fabric of space-time, gravitational waves whispering across the cosmos. When black holes merge, the universe itself shudders. These shudders are gravitational waves, ripples in the very fabric of space-time. They travel outward like the ripples from a stone dropped into a pond, except the pond is infinite, and the ripples never fade entirely. They are the quiet whispers of the universe's most dramatic events. These waves carry information across billions of light-years, telling us about collisions we could never see otherwise. Each ripple encodes the mass of the black holes, their speed, even the angle at which they spiral together. To listen to them is to hear the heartbeat of the cosmos. Unlike light, which can be blocked or absorbed, gravitational waves pass through everything: stars, gas, planets, even us. They reach Earth unchanged, tiny distortions stretching and compressing space itself. Sensitive detectors catch them, recording moments that happened long before humanity ever existed. We are eavesdropping on the universe's oldest conversations, and what's most humbling is how faint they are. By the time they reach us, the ripples are smaller than the width of a proton. Yet our instruments can detect them, proof of human ingenuity meeting cosmic immensity. To measure them is to touch the fabric of reality itself. So when galaxies collide, their black holes merge and gravitational waves ripple outward, the universe tells its story in silence. Not with light, not with sound, but with the gentle whisper of space-time itself, carrying news of cosmic unions across eternity. Planetary systems shaken, but not shattered. When we hear galactic collision, our minds jump to worlds colliding, planets breaking apart, skies on fire. But the truth is gentler. Stars are so far apart that even during collisions, most planets remain untouched. Instead of being shattered, planetary systems are mostly shaken. Their orbits tugged, their skies altered. It is the difference between a city destroyed and a city suddenly moved to a new continent. Imagine a planet orbiting a calm sun. For billions of years, its night sky is familiar. But as galaxies collide, the planet's star may be tugged into a new path, pulling the planet along. From the ground, the sky would slowly change as new constellations crept in and old ones faded. The planet itself, though, would stay safe. The danger is not in direct impacts, but in gravitational disturbances. Passing stars can nudge comets, disturb asteroid belts, or alter the outer orbits of planets. Some worlds may be flung out of their systems entirely, becoming lonely wanderers. Others may find themselves in richer skies, closer to clusters of new stars born from the collision. For life, the changes might be subtle but profound. A once dark night could fill with brighter stars. New cosmic neighbors might rise above the horizon. The collision is not a fiery doom, but a reshaping of the view, as if the universe repainted the canvas of the sky. So galactic collisions rarely destroy planetary systems. Instead, they shake them gently, reminding us that even in the grandest upheavals, small worlds can endure, carrying life forward into new chapters. Solar neighborhoods drifting into new skies. A solar system is never truly isolated, lives in a stellar neighborhood. When galaxies collide, these neighborhoods drift, sometimes slowly, sometimes dramatically. Stars that were once distant neighbors draw closer, others drift away into new regions. It is like waking up to find your entire town has been carried to another valley, familiar yet transformed. For civilizations that might exist on distant planets, the change would be breathtaking. Imagine looking up at the night sky and seeing not just new constellations, but an entire second galaxy stretching across the heavens, glowing brighter each century. What was once a faint smear becomes a sprawling arch of light. The drifting neighborhoods also mean new possibilities. Stars carrying their planets may pass closer to gas clouds, offering raw material for comets and moons. Some may drift near stellar nurseries where the skies blaze with newborn suns. Others may wander into quieter regions, surrounded by silence and darkness. Every solar system carries its own journey through the collision. Even our own sun is not immune. In 4 billion years, as the Milky Way and Andromeda embrace, our solar system will drift into new skies. The constellations we know today will vanish, replaced by swirls of stars we cannot imagine. Earth, if still alive then, will look up into an alien sky painted by collision. So solar neighborhoods remind us that we are passengers. We do not control the journey, but we carry the gift of perspective, the chance to witness the universe's transformations from our small but steady worlds. Moons and worlds surviving the turmoil. Though galaxies collide, stars rarely touch, and planets almost never crash. This means that moons, worlds, and even fragile systems of rings often survive the turmoil. The collision is not fire-consuming everything, but a grand reshuffling of orbits and neighbors. The cosmos is vast enough to spare most of its smaller treasures. Moons continue to circle their planets, tides rise and fall, seasons unfold. Life, if it exists, would experience little disruption in daily rhythms. The greatest change would come in the night sky, where new galaxies loom larger and the heavens grow brighter with newborn stars. The internal life of a world might go on, unchanged, beneath skies transformed. Some planets may be ejected from their systems, becoming rogue wanderers. Even then, moons might still orbit them, carrying faint warmth from internal cores. Survival in the universe does not always mean stability. Sometimes it means adapting to journeys through endless night. Collisions give birth to such wanderers, carrying seeds of possibility across the cosmos. Others may find themselves enriched. Collisions scatter heavy elements, and planets forming afterward may carry richer minerals, denser atmospheres, or more complex chemistry. In this sense, galactic collisions are not just upheavals, but opportunities for new kinds of worlds to emerge. So while galaxies twist and bend, moons and worlds endure. They carry on their quiet revolutions, bearing witness to the cosmic storm from the safety of their orbits, like small boats floating on a restless but enduring sea. The strange calm inside stable zones. Even during the height of galactic collision, not everything is chaos. There are pockets of stability, regions where stars and planets barely notice the storm beyond. These zones remind us that in the midst of upheaval, there is always calm, always balance hiding somewhere. In stable zones, stars continue their orbits with little disturbance. Planets circle steadily, life thrives if it exists, and the skies, though different, are not overwhelming. From within, a civilization might sense only subtle changes over millennia. A brighter glow on the horizon, a shifting arch of stars, but not the terror of destruction. These stable regions exist because galaxies are mostly empty space. Even as they pass through one another, the chance of stars colliding directly is almost zero. The true chaos lies in gas clouds and gravitational tides, not in star-to-star impacts. For countless worlds, the collision is only background music, not the main melody of life. The calm zones are also important scientifically. They allow astronomers to compare, to see how stars and planets evolve normally versus how they change under tidal stress. The contrast reveals the hidden fingerprints of the collision, the quiet evidence amid the noise. So the strange calm of stable zones is a reminder. Even in cosmic upheavals, balance survives. The universe is not only storm and fire, it is also silence and stillness, holding steady even as galaxies dance around them. Life watching the dance from a safe distance.